All right, we have a Ferris wheel that's 10 meters in diameter and boarded from a platform that is 4 meters above the ground. The 6 o'clock position on the Ferris wheel, on the bottom, is level with the loading platform. The wheel completes one full revolution in 6 minutes, okay? The function, h equals f of t, gives you your height in meters above the ground, okay? T minutes after the wheel begins to turn. Write an equation for h equals f of t. Okay, so this will follow a function. Okay, so this will be either a sine or cosine function. Let's go ahead and determine that in a little bit. Let's just write down some of the key information from this problem. Okay, so the diameter, the diameter of the Ferris wheel is 10 meters. So this tells us that the radius is equal to 5 meters. Okay. The platform is 4 meters above the ground. So that's the lowest point. So if you think about the Ferris wheel, here's the circle, the Ferris wheel, and the distance from here to here is 4 meters. So just to visualize that. Okay, so the platform, the lowest point, we'll just say, is 4 meters above ground. I'll just say above. Okay, that's important information. Okay, the 6 o'clock position is level with the platform. That tells us that the function should start at the lowest point. So if we're starting at the lowest point, we're starting at the lowest point. So we start at the lowest point. So it's good to just jot down all the given information that we have in the problem. So one one full revolution is 6 minutes. So let's just write that. One full rev in 6 minutes. Just write that. Okay, that's all important, important information. So we need to write f of t. We need to find f of t. So and again, f of t gives you the height in meters above the ground in t minutes. Okay. Good. H. It's the height. All right. So we can pretty easily find the midline of our sine or cosine function. We'll determine if it's a sine or cosine function a little bit. The midline will end up being right down the middle of this line. So if the radius is 5 meters, then that tells us that the midline, because remember that this sine or cosine function represents the height above the ground, that height above the ground. So it's going to go back and forth between here and here like a sine or cosine function. But the middle of this is going to be the middle of that Ferris the Ferris wheel, yeah, Ferris wheel. So the midline we can determine pretty easily. And the standard form of the function is essentially f of t equals a sine or cosine. We'll figure that out. Sine or cosine b, and then t minus c plus d. So the midline that's the d value. The the midline is d, which equals the radius plus the 4 meters, because so the midline is actually 9 meters above the ground. 5 plus 4. So that's 9 meters. Okay. Now, the amplitude, we can figure that one out very similarly. Amplitude, which is equal to the A value. The amplitude is quite simply the radius. It's the distance between the midline and the top or the bottom of the sine or cosine function. So that is actually the radius. 5 meters. All right. We can also figure out the period based on how long the time, because t is time, input value is time, how long it takes to complete one complete period, which is 6 minutes. So we can figure out the period is 6 minutes. 6 minutes is equal to 2 pi over b. So we can actually find the value of b. Or actually, sorry, it's quite a little correction. The period is 6. Therefore, we can actually solve. Oh no, that's right. That's right. But more specifically, yeah. So 6 minutes equals 2 pi over b. So we can solve for that b value. Yeah, that we want to find the b. That's equal to, if you do a little bit of math, basic algebra, we'll find 2 pi over 6. B is equal to 2 pi over 6. And so B is equal to pi over 3. So we found D, A, and B. So now the horizontal shift, there is actually no horizontal shift. So the horizontal shift, which is equal to C, the horizontal shift is based on how much we shift left or right from the standard sine or cosine function. So based on this information, we would determine it based on the starting point. So the horizontal shift is based on the starting point. It's at its lowest point. So that tells us if the starting point, the beginning of our essentially t equals 0. So let's draw this really quick. So a cosine function is where you start up here. The basic cosine function looks something like that. Oh, why did it do that? It'll look something like that, and it'll start at the top of the curve at t equals 0. But what we're dealing with is the starting point is at its lowest point, the lowest point. So it's actually kind of inverted. It'll look something like that. And how we get the starting point at t equals 0, time equals 0, at its lowest point of the Ferris wheel, essentially, we need to just multiply the amplitude by -1. That'll just flip it about the horizontal, the x-axis, or t-axis. T is our input. So there's no horizontal shift. So that's non-existent. So to deal, why did it do that? So to deal with the start at the lowest point, that just tells us that we need the amplitude to be, instead of 5, it will become -5, the amplitude. So it'd be like A, instead of A, we would have -A. And we'll be dealing with the cosine function. We're going to be dealing with this cosine function here. So putting all this together, we would get the function f of t equals -5 cosine. So that just tells us that the cosine function is starting at the lowest point right there instead of the top point. And then yeah, and then we would have the b value. The b value is pi over 3. And then we would multiply that by t. And there's no minus c. There's no horizontal shift. So it's just pi over 3 times t inside the cosine. And then we have the midline being plus 9. And that will give us our function for the height of the Ferris wheel, given all the information in this problem, for after time t, where t equals 0 is the starting point at the bottom of the Ferris wheel. All right, let me know if you have any questions with this. It's a bit more complicated, but the idea is we're just dealing with the sine or cosine function and finding the different parts of it to build our function. All right, let me know if you have any questions.